That is the grade, guys. That is the grade. Grade 10. Grade 10. Grade 10. Grade 10. Hello, hello, hello. What a week it has been, hey, right? Can someone tell me how great or how amazing their week has been this week? I've been seeing a lot of what you might call comments coming through. Uh, Only him 08. There's only one subject that basically defines this channel, and you can see by the name of the channel. Only him 08. It cannot be any other subject. But do you want to give us a drum roll so that we can actually write the actual subject that is the main subject, the only subject occupies the utmost recesses of the mind of the people that are here. Here we go. Thank you so much. Guys, it seems like the network is not so great. Can you guys indicate? Okay, show the screen. So do I have some grade 10s in here? Can I just get an indication in the bottom there? Tatejo is saying, I guess what? Bye bye, only him. When I'm gonna do grade 11? Grade 11, I'm gonna see you guys at 9 o'clock. Yes, indeed. 9 o'clock, grade 11, and then grade 12 at 10:30 as usual. So we'll take the same trend. Grade 10 now, I'm having a session with you, grade 10 now. Grade 11 will have a session at 9 o'clock, and then grade 12 will have a session at 10:30. I think that's fair enough, right? I hope that's in order. That is in order. So grade 10, all right. I am actually not going to be doing anything in particular than what I have planned. So those who have been here for the longest time have seen me actually do live sessions one after the other. And there's sort of like a developmental, sort of like one topic after the other thing that I've been doing. Today I'm actually going to do algebraic fractions, guys. Algebraic fractions. This is a topic that follows after factorization in the syllabus. So the grade 10 learners that are here, you are going to be exposed to me actually do what? You are going to be exposed to me actually teach a new topic called simplification of algebraic, and I complete simplification of algebraic fractions. So that's what I'll be doing today with y'all. I just need to get an indication though. I just need to get an indication in the comment section that you guys can see me, or not see me, but see the screen, that you can see it very clearly, that the network connection is okay. It's not too shabby, it's not too hectic, but it's just pristine and the way it ought to be. So you can hear me clearly, and you can actually see on the screen clearly as well. All right, thank you, Unako Staffans. Unako, you are here. Unako kwenza, hey? All right. So I'm going to actually jump straight into what I'm going to be covering today. So like I said, factorization is a beautiful topic, right? Because factorization helps us to be able to factor any given expression. All right, when we are given an expression, we are able to factorize. So now today what we're going to look at is the simplification of algebraic fractions. And interestingly enough, with simplification of algebraic fractions, do you know what we need in order to be able to simplify algebraic fractions? We need factorization, guys. We need factorization, and we need to know factorization pretty well, if you ask me. So this section becomes a beauty and a joy when we know our factorization very well. Now you will remember that when you guys did factorization, you looked at how many different types of factorization. You looked at a few, right? A few, okay? Timen Mambunda, hello, by the way. I hope you are good. Bogamoso, I hope you're good as well. Tizest logo, hello. Basetsana, hello as well. You're joining in, I see you there. Kia, I hope you're good. To the beloved 20 odd people, especially those that are actually surfacing from my beloved group, you are more than welcome. I welcome you most warmly and heartily. Carol, Kia, T-Man, Bo, Bosho, Dira, Bo, J, Sizer, Lejapele, Fezile, Jumi, Tiza, Tulani, Loaza, K, Gathesia, was it Tisia, Charlene, and Unati? So welcome to all of y'all. So like I was saying, we are going to be looking at the simplification of algebraic fractions. So we are going to jump right into it. And yes, please use the comment section very wisely and sparingly. So if it is that there's something that I'm explaining and you do find yourself getting lost, use the comment section to quickly be able to alert me of things that you may not be clear about. I'm here to help, I'm here to assist, so let's get into it. So to start us off, guys, okay, we are going to look at the following expressions. Okay, the following expressions which have let me pause now. Okay, so we're going to check out the following expression. I'm sorry about that. We're going to check out the following expressions which have a single term, and I guess this is what will make these kinds of problems when it comes to simplification of algebraic expression. Following expressions which have single term denominators. So we're going to look at problems that have single term denominators. Now this is not new. In grade 9, you guys were exposed to this, or at least let me say ideally, if grade 9 was fully and completely taught in your respective schools, then you should have been exposed to this already. So this is not new at all right? And you're gonna see when I actually look at an example. So if they say simplify, all right, and we are given the following. Okay, I'm sure, I hope you guys can see this, all right? So we are told to do what? To simplify, all right? What we need to first establish, all right, is in the numerator, how many terms do we have, All right, and I'm sure you guys have heard me so many times ask this question over and over again. I'm sure some of you are like, my goodness, this guy, is he like obsessed with asking this question, how many terms we have? So if you look at the numerator, there are 2 terms. Thank you very much, God love. You have got that 100% correct. There are 2 terms in the denominator. In the numerator. How do we know that? It's because terms are separated always by a plus or a minus sign. In the denominator, we have how many terms, guys? Someone tell me how many terms we have in the denominator. So how many terms we have in the denominator? Sihlelusi, you are spot on. In the denominator, we have 1 term. So Sihlelusi and Tlatlengi, no CD, you guys have got it down. All right. So we need to then simplify this algebraic fraction, which we can clearly see has how many terms in the numerator? 2. In the denominator, 1. Now you will remember that whenever, okay, and I'm just going to expose us to sort of like 2 methods where this is concerned. So we know that at the numerator we have a binomial. In other words, we have 2 terms. In the denominator we have a monomial. Hence we said we are looking at the following expressions which have what? A single term denominator. So we're going to take it just from there. Okay, we're going to look at the types of questions where we have an algebraic fraction. So altogether, this here is a fraction. And when you guys did counting number of terms in grade 9, you will remember very clearly that if we were to holistically try and quantify, in other words, determine how many terms we have for this expression, what would you say? How many terms would you say is this expression? Let me see in the comment section. If I asked you how many terms are in this algebraic fraction, how many terms would you say? How many terms is this algebraic fraction expression? How many terms is this? Okay, Fiona says 2. No Seed says 3. Play-Doh says 3. Nhlanhla Manana says 3. CRS says 3. Mamelo says 3, and then there's a question mark. Kio Untlatleng says 1. Sihlelusi says 3. Then Godalove says and explains, I'd say 2 because division, that separate the numbers. Okay, Godalove is explaining. Untokozo Ndlovu says 1. Nanda says 3. Godalove says doesn't. Caesar says 1. Now listen up, guys, and listen up very well. Even though in the numerator we have 2 terms and in the denominator we have 1 term, if we quantify how many terms this expression represents, do you know what? A fraction, we are told, is actually 1 term. And you guys need to listen to this. So Sizwe was 100% correct. Ntokozo was 100% correct. Ntlatleng was 100% correct. Okay, so a fraction, doesn't matter how many terms in the numerator there are, how many terms in the denominator there are, a fraction is a single term. Please take note of that. Okay, please take note of that. All right, a fraction is a single term, because here's the logic that there is here. If we were to dismantle this and actually express it, we would say this is 3x squared plus 6x, and then the line, this line, okay, thank you Ntlatla for the rose. This line means what? It means divide, okay? And then we have a 3x squared on this side. But here's the thing, the terms in the numerator are actually 3x squared plus 6x, all right, which is obviously then that 1 term, divided by 3x squared. Now, if I was to ask you how many terms are represented in this expression, you would clearly say 1 term, all right? So please take note of this very important thing that I've just mentioned here, that a fraction is a what? It's a single term. Any fraction that is represented, doesn't matter how many terms there are in the numerator and how many terms there are in the denominator. The minute it's a fraction, we say it is a single term. That is something that should have been spelled out so clearly in your grade 8 syllabus and also in your grade 9 syllabus. And so coming into grade 10, you should be so sure about that. There should be no misgivings. Okay? So hopefully we are all together. All right? And there's a reason why I'm actually, saying this very earlier on in this simplification of an algebraic expression. Okay, now let's get back to the question, because all of what I've said was just us being able to be aware of what we are seeing in the fraction, so that we are not, we don't have any misgivings about what's here. Okay, so let's proceed now. Since we've established that there are two terms in the numerator and there's one term in the denominator, but because this is a fraction, this is one term. How do we go about then simplifying this fraction? So I'm going to say to you now, in grade 9, you should have been exposed to two methods. Why? Because initially factorization was something you did not know. So had you done this before factorization, you would have known that there's a method whereby you can simplify this, all right? But the minute you know factorization, then the method that you can utilize is whereby you are going to factorize. So let us proceed and check out the factorization method, because we've just come from learning about all of the factorization methods and we know what they entail, okay? Hopefully, as we go along, we'll also be able to remember the factorization methods that we have learned, and that will actually, sort of like also help us to speed up our mental knowledge. Okay. So let me very quickly then just rub out what I had written down here. And I'm sorry for the dark screen, but sometimes it has to be dark in order for there to be light. Okay, so here we are, guys. So we have two terms in the numerator, we have one term in the denominator. Question: can we factorize what's in the numerator? That's the question. Can we factorize what is in the numerator? If we can, please suggest how. Mamelo says yes, indeed we can. Can we factorize what's in the numerator? Mamelo says yes. Okay. Now, what type of factorization can we apply in the numerator? I'm sure you guys know that I typically like asking these questions. Before you factorize, I ask how many terms are in the expression. Then you tell me. Then the second question is there a highest common factor? That is the first question we always ask ourselves whenever we are required to factorize something. So if you can factorize the numerator, you apply a relevant type of factorization and you factorize it accordingly. So Mamelo is like on fire there, and she is saying take out 3x. We are taking out a common factor. In fact, a highest common factor, which is very true, Mamelo. Well done to you. So 3x squared plus 6x, okay, there is a highest common factor here. So that is what we can do. We can take out the highest common factor. Now you'll remember that I said to you, whenever you take out the highest common factor, you take it out according to SNL. What does SNL stand for? No, it is not the symbols that you see in a TV screen for all the shows that you shouldn't be watching at all. But it stands for S means sign, N means number, L means letter. So you take out your highest common factor according to the sign, number, and letter. The sign, if the first term, whatever the sign of the first term is, it means the sign of that first term is what you take out as your highest common factor. So in this case, 3x squared plus 6x, the first term is positive. So the positive sign is something that we take out. Hence, your highest common factor is a positive expression. 2, number. You take out your highest common factor number. Now, what is your highest common factor number? Simply, your highest common factor is that number that basically goes into, it's the highest number that goes into 3 and 6. And in this case, it is definitely what? 3. And then last but not least, your letter, or in other words, your variable. Your highest common factor variable will always be the common variable or the common letter for all terms that has the lowest exponent. Okay, so this is me sort of like also kind of assisting you guys to kind of recap on what it means to take out the highest common factor. So for sign, you always take out the sign of the first term. For number, you take out the number that is a common factor for all terms, the number that goes into all the terms, the highest number that goes into all the terms. And then lastly, the letter, the variable. You take out the common variable that has the lowest exponent. So if you look at all of these factors and take them into consideration, 3x squared plus 6x, the highest common factor is, it's positive 3, because 3 goes into 3 and goes into 6, leaves no remainder. Then x squared and x, the x is common, but the one that has the lowest exponent is x. That is what you take out. Now you open the bracket. What's left inside? So you took out 3, there's a 3 there already. You took out x, you suppose you are wanting to have x squared. So if you take out 1x, but you want 2 of these x's, how many do you need to add? You need to add 1 more. Then, since this was positive, a positive times what gives you a positive, obviously that is positive. And then 3x times what gives you 6x. 3 times what gives you 6. Or in other words, what's 6 divided by 3? That is 2. You took out an x, you needed an x at the end. Do you need to add any more? Definitely not. So that's basically how you factorize the numerator. Highest common factor factorization, done and dusted. Over 3x squared. Now guys, do you see how beautiful this is? Can you really factorize what's in the denominator? Okay, all right. This is one term in the denominator. Okay, so basically, I mean really. Okay, now there's something that we then do here, which is, since this is clearly one term in the numerator and this is one term in the denominator, you are now able to cancel what is common. I repeat, since you can clearly see this is one term in the numerator and this is one term in the denominator, 3x, okay, has a relationship of multiply with x plus 2. The x plus 2 together becomes one term. You can now do the following. You cannot cancel this x and this x. Please, guys, you can't do that. Why? Because this x has a relationship of addition with this 2. We can never cancel across an addition sign or a subtraction sign. It is not allowed. But this x and this x can definitely be cancelled. Why? Because the relationship that exists with 3x with the x plus 2 is one of multiplication. It's not across an addition or a subtraction sign that we are cancelling those two. So with that said, this is like saying 3x divided by 3. Now that 3 and the 3 will cancel. In other words, what's 3? 3 goes into 3 how many times? That's once in the numerator. Okay, and then 3 goes in 3 how many times in the denominator? Once. I hope that makes sense. Okay, so that's why we have 1 and 1. Now we have x and x squared. So you have this x in the numerator, you cancel that, and this x in the denominator, you cancel that. That means you are left with a single x in the denominator. In the numerator, that x is no longer there. So what you are left with in the numerator is x plus 2. So therefore, our final answer can simply be x plus 2 over x. Now, if ever you become tempted to want to cancel this x and this x, just remember this one rule. You cannot cancel across a addition sign or a subtraction sign. So the answer is simply x plus 2 over x. We have now simplified this algebraic fraction. Okay, so I don't know if anyone has any specific questions. I am more than happy to entertain those questions if there are any. Grade 10s, is this clear for you? Okay, simplification of an algebraic fraction where there are 2 terms in the numerator and 1 term in the denominator. all you need to do, all right, when you are simplifying algebraic fractions where there are a numerous number of terms in the numerator and one term, because we are specifically looking at where there's one term in the denominator. Thank you so much, Lungisani, for the 10 roses. Really appreciate it. What we simply do here is we've ascertained that there are two terms in the numerator. There is one term in the denominator. So what we do is in the numerator, because there are two terms in the numerator, we identify there are two terms, which means there's a binomial in the numerator. In the denominator, there is one term, meaning there's a monomial in the denominator. What we then do is we look at that numerator that has two terms, and we do what? We factorize. Why are we factorizing? It is because the question says we need to simplify the algebraic fraction. And because there are two terms in the numerator, factorization ought to be applied where factorization is possible. So the way we go about factorizing fractions where there are a numerous number of terms in the numerator and one term specifically, because we are looking at one term denominator type questions, we simply factorize the numerator, okay, apply a relevant type of factorization, okay, and then as for the denominator, this is one term, okay, and since it's one term, remember factorization is applied most effectively when there are two or more terms, because remember we have how many types of factorization? There are a numerous number of factorization types. We have highest common factor, we have difference of two squares, we have trinomial factorization, we have advanced trinomial factorization, we have cubic factorization. So we can clearly see that the numerator can be factorized, whereas the denominator is a single term, which basically retains its what? Identity. But do you know what, guys? As we go further to other simplification of algebraic fraction type questions, when we simply slowly but surely move away from one term denominators, you guys will see how the method, okay, or how the approach, slightly changes. But for now, because the numerator is the only expression that can be factorized, we factorize it, okay? Shante is asking, step 3, how did you find the 1x in the denominator? Because it had a square root. The 1x did not have a square root, Shante. Please let us say the things right. The 3x had a squared, okay? So the 3x, the x was squared. Remember, a square root is this thing, okay? Say it right. Remember, Shante, you might have siblings at home. One day, those siblings will come to you and be like, sister, could you please explain to me what this is? And if you, in any way, will begin to say the wrong things and say, this is a square root, the kids might simply lose confidence in you. So it's very important to say the things the way that they are. So this is a square root, Shante. This is simply the x is squared, okay? So this is a square term. All right, so I guess you were asking, how did I eventually get x in the denominator? I'm just going to explain that very quickly. So firstly, we factorize 3x squared plus 6x. What do we do when we factorize 3x squared plus 6x? I said we ask ourselves, the first question for any type of factorization, whenever we want to approach and apply factorization, we always ask the very most important question, and that is there a highest common factor in these two terms? And I explained that when you take out your highest common factor, you do it according to sign, number, letter. And I said, guys, these are not the fancy little letters that you see on the TV screen when you're watching movies that you ought not to be watching. This means, S means sign, so you take out your highest common factor sign, which is always denoted by the first term. Your first term gives you an indication as to which sign you ought to take out as your highest common factor. So in this situation here, 3x squared, which is the first term, that means we take out a positive as our sign, which is the highest common factor. Then we move on to number. The highest common factor number, so between 3 and 6, Which one is the highest common factor? The number that simply goes into 3 and goes into 6. The highest common factor number is 3. Then you move on to the highest common factor letter. And I said when we take out the highest common factor variable, guys, please, very importantly, the letter that becomes the highest common factor is the common variable. And by variable, I mean the alphabetical letter that is common. That has the lowest exponent. So if you look at x squared and x, they are common, but which one has the lowest exponent? It is x. So that's why we take out 3x as the highest common factor. Then, what is left inside? 3x times what gives us 3x squared? So you took out 3x, and you know that when x and x are multiplied, if the bases are the same, according to exponents, we keep the base, we add the exponent. So 1x plus another times another x means that we add the exponents, we get the 2, which is the exponent for x back again. Then what's 3x times what will give us 6? We simply know that 3x, we need to multiply it by 2 to get 6x back. And that's why we have x plus 2 in the brackets. Then our 3x squared is simply the way it was. Then from here, guys, at this stage, very importantly, I'm just going to rewrite that stage so that you guys can see very clearly what I mean by it. 3x squared. Simply put, 3x into x plus 2 means this now has become one term. Why do we say the numerator now is one term? It's because 3x and the brackets have a relationship of multiply, because brackets mean multiply and brackets combine terms. So 3x into x plus 2 is one term in the numerator, and 3x squared in the denominator is also one term. So we can simply now apply something that we refer to as cancellation. You can cancel, but you cannot cancel. You cannot, please people, we cannot cancel across an addition or subtraction sign. We simply cannot do it. Okay? We simply cannot do it. So at this stage, there's 3x divided by 3x squared. The relationship between 3x and x plus 2 is one of multiplication. So therefore, 3x divided by 3x squared, I mean, you guys simplify that, okay? You say 3 divided by 3. So in other words, what's the highest common factor between 3 and 3? The highest common factor between 3 and 3 is 3. So 3 goes into 3 how many times? Once. 3 goes into 3 how many times in the denominator? Once. So that's where the 1 comes from. This 1 that you see here, and that 1 in the numerator that you see there. Then look at x. Same thing. What is the highest common factor between x and x squared? It is what? It is x. All right? But x goes into x once, whereas x goes into x squared. Now, obviously, here we are going to have a single x remaining in the denominator. So that is why in the denominator we end up having 1x. So that's why when you are finished, you actually say the answer is 1 into x plus 2 over x. All right. If you look at here, I simply avoided having to do all of those cancellations because it would have just resulted in things being very untidy. So what I did do, I did this mentally. And I said 3 goes into 3 how many times? Once. So 3 goes into 3 once. So that's why it's 1 over 1. Then with the x, obviously, if I cancel this x and this x, the x in the denominator simply ceases to exist, whereas the x in the numerator, in the denominator, if there was two of these x's, because of this x, there's one x that remains. Okay, so 1 into x plus 2 into 1x. And our final answer can simply be x plus 2 over x. Linda Swartz, in my bio. It's also called Maths is a Game. All right. It's also called Maths is a Game. And yeah, you can just go on there and yeah, I have done all the prior lessons before simplification of algebraic fractions. Okay. Mamelo, I do offer tutoring. All right. I absolutely do. But I must say my time is so munched up. This year I have a grade 12 class And yeah, I am really trying to give my absolute all to them, physically speaking. So what you can do is just send me a DM privately, and then I'll get back to you, and we can have a conversation on the side. Okay. All right, guys. I hope that one was very clear. So let's look at another example. Very similar one. Okay. Let's look at it, and let's look at it. Okay. What I love about these problems, the minute you actually get to have an understanding of this, then mentally you can start doing the maths in your head. You start seeing it in your head. So once again, let's look at this problem. Numerator, how many terms? There are 2 terms. Denominator, how many terms? There is 1 term. Remember, we are still looking at the types of problems where we have 1 term in the denominator. So then it stands to reason that if we look at the numerator, there are 2 terms. What can we expect? Step number 1, factorize if possible. So we look at the numerator and we factorize if possible. Tudo, this is not grade 9 specifically, it's grade 10. But you will find that later on in your grade 9 syllabus, you will learn about this, okay? So I wouldn't really advise you to tune in now, because you have other things you need to be focusing on as far as your syllabus is concerned, and you don't want to be focusing on something that you will only be focusing on later on. I think you guys focus on this on the 3rd term. Okay. Grade 11, I'll be seeing you guys at 9 o'clock, and then grade 12, I'll see you at 10:30. Okay. So 12x to the power 3y plus 3xy. So if you look at the numerator, there are 2 terms, which means we can factorize. If we look at it, what type of factorization can we apply? So once again, it seems like highest common factor factorization wins. So what do? We take out the highest common factor according to the sign, number, letter. And like I said, these are not the exciting or maybe like scary symbols that you see on your television screen, movies that you shouldn't watch. Really advise against those movies, by the way, really and truly. So sign, number, letter anyways. If we look at the first term, it's positive. So that means our highest common factor sign will be positive. Okay. Number 12 and 3. What is the highest common factor between 12 and 3? I think the comment section can actually go wild. Let us go wild in the comment section and come out with what is the highest common factor between 12 and 3. Let's go wild. Yes, Landy, you are definitely. It's 3. It's 3. Mzumero. It can't be 12. It's 3. It's 3. Remember, that number needs to fit into 12, and it has to also fit into 3. So if you say the highest common factor number is 12, remember 12 cannot fit itself into 3, right? Let us be very careful with that. When I say highest common factor, okay, where the number is concerned, 12 and 3, you're wanting to find out which number fits in to 12, okay? It is 3. The highest number that fits into 12 is 3, okay? And the highest factor number that fits into 3 is also 3. Do you understand? If you said it's 12, look at this. 12, yes, does fit into 12, but does 12 fit into 3? Yo, guys, like you guys are saying 3 is very big. It has to, allow itself to be big enough to allow 12 to fit into it. It's like taking this very big guy, like Big Show from like WW whatever, and fitting him into Rey Mysterio. Aye, guys, doesn't work that way. Big Show, fit Big Show into Rey Mysterio. Aye, guys, aye, come on. It's like taking an elephant and trying to force feed it down to someone's mouth. No, it's not good. Okay, so highest common factor number is 3. Then letter. Okay, highest common factor letter. Remember, I specifically told you that for letters, you look for the common variable that has the lowest exponent. Common variable that has the lowest exponent. Now, the variables you have here are x cubed and x. You look at them both and you ask yourself, for x alone, which one has the lowest exponent? X cubed or x? Okay, obviously it is x. So for x, we've already identified which common variable has the lowest exponent, because that is our highest common factor variable. Are we together? Then for y and for y, which one has the lowest exponent? Obviously, they both have a common one, so we take out y once. And there we have it. 3x positive 3xy is our highest common factor. Let's go and take it out. Take him out. Take him out. We've taken him out. There he is, 3xy. Now, we need to figure out who's left inside after we took 3xy out. We need to make 12. 3 is out. So the question is 3 times what is 12? This is grade 10. Okay, grade 10. Simplifying algebraic fractions. That's what we are looking at. Yes, Lee. Oh, Lee. Oh, Lee. Lee. Jet Lee. Nice. Very nice. Okay. Would you mind repeating SNL? So you've never heard of SNL. Guys, okay, let me just patience there, guys, for me. Okay, Bosisi when they wants to know SNL. Bosi, if you look at whenever we are taking out, if we look at two terms, and we see, yes, I'm going to post it on the YouTube channel, obvious. If you look at two terms and you see that you want to take, and you can see that there's the highest common factor, you can apply highest common factor factorization. What you do is when you take out that highest common factor, you take it out according to the sign, according to the number, according to the letter. This is this S and L that I'm talking about, Busi. Sign, number, letter. So we look at the two terms. And the first term, its sign is always the one that we take out as the highest common factor. What? Sign. Are you with me? The sign of the first term, whatever that sign is, whether it's positive, whether it's negative, we always take it out as the highest common factor sign. Then we follow it up with the what? With the number. Yes, it is Planet Aubrey. Then you follow it with the number. 12 and 3. What is the highest common factor number? We look for that number, the highest number that can fit into 12 without leaving a remainder, and fit into 3 without leaving a remainder. So if you look at 12 and 3, which is that highest number that fits into both without leaving a remainder? It is 3. Are you with me? It can't be 12. We can't say 12 is the highest common factor, because 12, yes, fits into itself, but 12 does not fit into 3. That's like taking an elephant and trying to force feed it down your throat. It's not going to happen. Okay? It's not going to happen. So 3 goes into 12 and 3. That is the highest common factor number. Then we move on to letter. I said when we take out the highest common factor letter or variable, we look for the common variable that has the lowest exponent. The lowest exponent. This is very important. The common. So x cubed and x are common. But which one has the lowest exponent? It is x. Okay? Does that make sense, guys? It is x. So we take out x. We can't take out x cubed. We go for the variable that has the lowest exponent. Remember, the exponent that is there here that you cannot see is 1. It's like the Holy Ghost, the Holy Spirit. Cannot see it, but it's there. So we take out x. Then for y, we look for the common variable that has the lowest exponent. But these ones both have the same exponent. So you take out y. Are you with me? So that's how we use S and L to identify our highest common factor. It's just a way, guys. Some people know this mentally, like it's nobody's business. Some people don't even have to consider something like S and L. But for someone who may be struggling with factorizing and taking out the highest common factor, then in your mind you have this logical order thing that you have of S and L. You remember it from the movies, but every time you're like, it can't be the movies. It has to be maths. It has to be factorization. It has to be taking out the highest common factor. And it doesn't stand for what you think it is. It's sign, number, letter. Okay? So the sign is also important, because remember, the minute the sign, we want to take out the sign as well, right? Yeah, and we do that naturally. It's like we don't say plus, but we know this 3 is what? It's positive. If the first term was negative, guys, it's very important to take out that negative sign, so that everything that's left inside the bracket gets affected because there's a negative sign that has been taken out. So by Godhead uncle, I hope you are seeing what the uncle of maths is a game is saying to us. Okay, let's go, guys. We take out the 3xy. Then, like I said, if we take it out, what's left? So we'll consider again the sign. Positive is out. Times what gives us back a positive? Obviously, it's a positive. So that's why this number is positive. It's positive. And then 3 times what gives us 12? Okanye, you can say 12 divided by 3. And then you get your answer. Can you use it? 12 divided by 3 is? There, the answer is 4. Then x. You took out 1x. You want to have 3 of these x's at the end. How many more x's do you need? That Ali Oipa, it's definitely x to the power 2. You took out 1x. You want 3 at the end. How many do you need to add? 2 of them. You took out 1y. You need 1 at the end. Do you need to add any more? No. So the answer here is 4x squared alone for your first term on the left. Then 3xy times what gives you positive? It's another positive. So inside the bracket, the signs are not, they are remaining the same because we took out a positive. The only time signs in the inside they change is when we take out a negative. You're going to see the sign changing. Then 3xy times what gives us 3xy? So 3 times what gives us 3? Or 3 divided by 3 is what? It's 1. The x, obviously, we don't need to add any other x. The y we took out, do we need to add more? We don't need. So therefore, we have closed bracket. So beautiful, guys. Then in the denominator, we have 9y squared. Are we ready to do the things that we want to do? What do we now have in the numerator? 1 term. Why do we say 1 term? Because brackets combine these, and then the relationship between 3xy and the bracket is multiplied. So it's 1. Then in the denominator we have 1. Now 9y squared and 3xy, definitely there we can cancel. Okay? Yeah. Planet Aubrey, I am a bit ahead here. Why? Because those who have been part of this Maths is a Game, adventure, will know that I have been busy teaching the grade 10 syllabus since December, when you guys were lasharing them lands and doing the things and partying. I was doing the things in this platform, and my kids that were joining, those who had actually caught onto my fire whilst I was busy in the holiday, they started with me. They were on a journey. Then I posted the lessons there on the YouTube channel for those that basically were there. Those that were there saying to me, you are teaching maths in December. Let our kids have the freedom to enjoy what they want to enjoy. I was like, no, I am pushing this thing. So those who have been with me, they are enjoying the benefits of being ahead. They are ahead in the syllabus because they've been with me and we've been working very hard. So now we find ourselves here on algebraic fractions where we are simplifying. If you want to be caught up, you can go to my YouTube channel. Link is on my bio. You can watch the lessons that we've done so far. You can polish up on your mathematics and be good and be sweet, so that in grade 10 you can feel good about the maths. You can start feeling level 7 is a possibility, So that's what's been happening. Planet Aubrey, I hope you are answered fully and completely. And my kids who are here, who have been with me on the journey, like your Landiwe 38 there with I think that one is an apple juice. It's apple juice there in that champagne bottle, in that champagne glass. It's not really the thing that you think it is. She will tell you that we've been on this thing and we've been learning very hard. So as a result, we are here. All right, you can be caught up and be with us, and you can continue. So yes, thank you very much, Landiwe, for confirming the apple juice nature of your the contents of what you had there. Thank you very much. Yes, apple juice on a Friday night is very, very key for a math student who's very serious about key marks. Right? Okay, now let's move on to the next step. 1 term in the numerator, as we've explained, 1 term in the denominator. 3xy is hungry to be cancelled. 3 and 9, highest common factor between 3 and 9. 3 goes into 3 how many times? Once. Okay, and then
if we look at 3, how many times does 3, because 3 is the highest common factor between 3, how many times does 3 go into 9? 3 times. I hope you guys can see this. You see? Then we have x. X remains because there's nothing in the denominator that can cancel with x. What about y? There's y and there's y squared. There are 2 of them here, there's 1. So we cancel. 1 disappears in the denominator. This one disappears in the numerator. There's no more y's in the numerator. But how many y's are in the denominator? There's no longer 2, but there's 1. Then what's left? 4x squared plus 1. We know that the final beautiful answer of ours is x, all right? Very importantly, x into 4x squared plus 1, okay? And there's nothing more that can be cancelled. So that is as simplified as we can be, okay? Guys, I really hope this is really helping when we have numerous number of terms in the numerator, 1 term in the denominator. We factorize the numerator, then we cancel what is common. And I love what Planet Aubrey said, laws of exponents, very important, because I'm sure you guys can even see that even if you apply your law of exponents, this basically makes sense why we have 1y in the denominator and basically the x still retains its identity in the numerator. Okay. So whenever the numerator has 2 terms, we can do that. Bigoted, bigoted uncle, thank you so much. Really appreciate the beautiful rose. You know, it's so nice to get flowers. I'm male and everything, and I know that like people are like, come on. Okay, guys, let's look at this one. Okay, so may I ask, is there a chance we are going to factorize the answer to get the question? So may I ask, is there a chance where we are going to factorize the answer to get the question? Oh, factorize the answer to get the question. All right, so I don't know if I'm understanding this. I don't know if I'm understanding what you're saying. Factorize the answer. Okay, because when we are here, guys, we cannot factorize any further. Okay, like it's done, we are finished. You don't understand why I got 3y. Okay, let's go back. Yeah, okay. Yeah, Ali Oipa is also like very much assisting there, because look at 4x squared plus 1. You cannot factorize this. Don't be fooled. Remember, this is the sum of 2 squares. Sum of 2 squares, unfactorized, right? But if it was difference of 2 squares, no, we would go ahead, hey? But this is not, it's not it, eh? Yeah. So hopefully, Landiwe, maybe, I think you were thinking that because of, you were like, this is a perfect square. Yes. This is a perfect square. Yes. But is there a negative in between? No. All right. So therefore, that's not applied. Just to answer the person that said they don't understand how we got 3y, please just think with me here. This is 3xy, right? Over 9y squared. So what I'm saying is cancellation can happen between these two. In other words, this is no different from me saying what is 3xy divided by 9y squared. It's like I'm looking at this solitarily, okay? And remember, when we simplify, we simplify according to sign, number, letter. Look at the number. 3 goes into 3 and 9. What is the highest common factor between 3 and 9? Because remember, when you simplify for division, for numbers, you ask, is there a highest common factor? So between 3 and 9, there is a highest common factor. What is that highest common factor? It is 3. So your question that you are asking yourself, 3 goes into 3 how many times? Once. 3 goes into 9 how many times? 3. Do you see now? Okay. Then with x has no complementary variable base in the denominator. So x is untouched. Nothing happens to him. Y, on the other hand, you have y and y to the power 2. Okay. Some people could apply laws of exponents, which is perfectly fine. But also at the same time, like I said, y divided by y squared. How many y's are at the top? 1. How many y's are at the bottom? 2. Okay. So therefore, if we cancel the y and the y, okay, the y at the top disappears because it cancels out the y in the denominator. But since one of them were cancelled for the numerator and the denominator, how many are left in the denominator? Since we cancelled 1 in the denominator, that means we left with a single y. So that's why in the denominator we have 3y, and then in the numerator we have 1x. Because remember, that y and that y, the one left and the other one stayed behind. So that's why we have x over 3xy. Yes, the x doesn't disappear. Why does the x not disappear? Because remember, like I said, x as a variable in the numerator, there's no x. There's nothing that has x in the denominator. So therefore, that x remains. Okay? Okay? That x remains. So I hope you guys get it. Okay? That it's got you. That you've got each other. Okay? I want to move on and just do another one. Okay? This time round, please take note of what we have. Okay? Please take note this time round what we have. So before we jump into it, Planet Aubrey, do you do past papers sometimes with us on live? Yes, but I will not do past papers until I feel confident that we have covered the concept in the syllabus. Then when the time comes when tests will be written, I'll be happy to do past papers with you. Why? Because at least we will have known that we've covered the content. So that's what's key for me. What's key for me is my beautiful learners being able to first understand the concept first, as per the syllabus. Once we understand the concept as per the syllabus and we've gone through numerous exercises together, and I give you a chance to also go and do some game challenges. I call them game challenges here. Whenever I finish and then I give you some work to do on your own, these are game challenges for you to apply and see where you stand with what we were doing, so that you can also see if you can do it on your own. All right, if you have mastered the concept, there's this thing that I really have I'm very obsessed with this thing, that you must first learn and understand. L means to learn, U means to understand, and then M, you need to master the concept. How you master it is through game challenges, doing more and more. So you must first learn though and understand what you have learned and know how it is applied. Then you go and do some game challenges so that you can master, that particular concept. Okay? So let's look at this, guys. X squared minus 12x plus 27 in the numerator. In the denominator, we have 4x squared minus 12x. Now we are moving to a new type of question. It's still algebraic fractions, but what's different this time? In the numerator, we have 3 terms. In the denominator, we have 2 terms. Now, what does that say to you? Guys, those who have been here for the longest time, they know every time this say, is about to factorize, he always asks this question: how many terms are in the expression? So if you look at the numerator here and the denominator, how many terms are in the numerator? There are 3 terms. How many terms are in the denominator? There are 2 terms. Next step, we need to factorize. Because 3 terms suggest that we can factorize if factorization is possible. Then if you look at the denominator as well, there are 2 terms. So that means what? 2 terms also suggest that we can factorize if possible. So remember, people, this is a thing of first be able to check how many terms. Remember that 2 or more terms implies that factorization may be possible. So if it is, we go ahead and we do it. Okay, so this is very important. Okay, and this is basically what we were doing as well, even in the previous problems. But it's just that we always knew that with the previous examples, we were always going to have one term in the denominator. Now we seem to have two or more terms in the numerator and two or more terms in the denominator. So how then do we proceed? We factorize if what? If possible. If we look at the numerator, we have what in the numerator? We have three terms. Do we have a highest common factor in the numerator? Now, I want to see if my people remember what I've been saying and what I always say in my live sessions. X squared minus 12x plus 27. Do we have a highest common factor in the numerator? Because I will see my sheep who hear me, who hear my voice, that listen and they give heed. And we have always said this thing, right? And I will see those people who are true sheep that listen. Do we have a highest common factor in the numerator? I'm still asking that question before I jump into anything. Okay. Gatli says no. Elita says no. By Gotted Uncle says technically yes, but it's one. No Seed says no. Tabiso says no. I'm just looking for my sheep, the ones that have been here all along in the journey, to actually say whatever they want to say. I'm still seeing unfamiliar faces. Okay. Mushle says no. Busisiwe says no, there's no highest common factor. We just arrived. Elihle says we just arrived. Now that's a very hilarious comment. Okay, guys, please listen. I loved the person who said technically, yes. And I want to say resoundingly, yes, there is a highest common factor in the expression. X squared minus 12x plus 27, I asked the question, is there highest common factor? And people said no in the majority. But in the numerator, there is a highest common factor, and technically it is 1, and I love that. But you remember I said it does not hold any real significance, because if we take out that 1, we still have the expression x squared minus 12x plus 27. So we tend to not really take note of it, but look at what we do next. What type of expression is this, guys? What type of expression is this? I need that now. Okay. 1 is common, very much so. It's the highest common factor. What type of expression is this? Yes, it's a trinomial, obviously, but I need this word. There's this word I'm looking for. It starts with Q. It's a trinomial, but what type of trinomial? Yes, it will, Mumushla. I said, very, very nice. Man, I love when people say the words that I want. Okay, Snoopy, 31, quadratic. Yes, it's a quadratic expression. Quadratic expression has as its highest exponent 2, followed by an x term, followed by a constant term, when it is in standard form expression. Please, people. What do we know about a quadratic trinomial when it comes to factorization? We can factorizing doing what? Opening two brackets. We can factorize opening two brackets. And guys, can I tell you something very interesting? The minute you open those two brackets, do you know what is standing here on the outside that you cannot see? That number that you guys said, it is that number that you guys said does not change anything. It's 1. 1 is there, exactly. So do you see that 1 is actually a highest common factor that you take out without even realizing? But we don't see it, but it's there. Hey, guys, things that you see, but they are there. Okay, anyways, let's stop right there. Then, look at the trinomial. Our constant is positive. What does that mean? Hey, now I'm going to see the people that have been here for the longest time. When we factorize a quadratic trinomial, there are things that we need to consider. Positive 27 means what about the bracket? If the constant is positive, what does it mean about inside the bracket as far as the signs are concerned? Hey, let's see if people have been really listening to me when I've been explaining these things. Zia. It means that the signs inside will be negative. We say that whenever the constant is positive, that means what? Same signs. Same signs. Positive constant term means the signs will be the same. According to who? According to the sign of the middle term. Hey people, and we said this thing. Positive constant term means that the signs will be the same inside the bracket. According to who? According to the sign of the middle term. And remember, I did explain that positive 27 is like the father. Negative sign 12 is like the mother. Who dictates the mood inside the brackets, inside the home? It's the mother. The mood is dictated by the mother. Okay, please people, this only applies for when the constant term is positive. Then we know that the signs will be the same. Same according to who? According to the mother. Mother dictates the mood in the home. If you don't believe me, just go to your mother right now. Check what's being cooked. Check the smell in the house. Was supper good? Is mommy feeling good? Do you see where the danger is? Okay, so please people, positive constant term means same signs inside the bracket according to the sign of the middle term. So minus signs are taken care of. We don't have to worry. X squared, x and x. But what's left now? The factors of who? Of 27. These factors of 27, when we add them, they need to give me negative 12. We already know that the signs are negative. That negative, the other one needs to give me, when I add it, negative 12. What are the factors, guys? What are the factors? Those factors of 27, when I add them together, need to give me the mother, negative 12. When I multiply, they need to give me the father, positive 27. So factors, Lerato says minus 3 and minus 9. Victorious, I see what you mean. Landio, I see what you mean. I see what you mean. So yes. Whether you put the 3 here and put the 9 there or the 9 there, the 3 there is of no significance for same signs. There it is. In the numerator, we are sorted. Guys, do you know that there's marks just attached to that factorization? The learner that has not mastered factorization at this stage simply sabotages their progress in this topic. Please, guys, master your factorization. I beg you. I beg you from the innermost depths of my heart. Please, please, please master factorization. Because if you do that, you will be fine. Then let's move. In the denominator, 4x squared minus 12x. What do we do there? What is the highest common factor there? What do we do there in the denominator? Yes, I am covering, okay, there's no other way. Yes, guys, you can see there. No trinomial factorization. We have a highest common factor because that's the question we always ask. Is there highest common factor? Okay. China says, don't we include the x next to the negative 12? I don't understand my beautiful China there. What is China saying to me? China girl, what are you saying there? China or China? Don't we include the x next to the negative 12? There's a negative 12x most there. Alright? Yeah. And then when I factorized, I got negative 9 and negative 3 for my factors of 27. When I multiply these two, negative times a negative, I get a positive. 9 times 3, I get that 27 back. For my middle term, negative 9x, negative 3x gives me negative 12x. So that's fine. I don't know my China, what's happening there, but you can explain more to me. Maybe In the denominator, there you can see that there's a highest common factor. You guys told me already, it's 4x. Then, but you do it according to sign number let. The factor is positive. The number, the first term is positive. So it's positive. Positive what? 4. 4 and 12. Highest common factor for 4 and 12 It's 4. 4 fits into 4 and 4 fits into 12. You see? So it is 4. X squared and x, the highest common factor, variable. We take the variable that has the lowest exponent. It's x. What's left inside? What's left inside? Yeah, people are doing the things there. I see you in the comment section. I love it. 4x times what gives me 4x? The 4 is fine. 4 times 1 is 4. X times, we got x. That's 1 out. We need 2. How many more do we need to add? We need to add 1 more. Then on the other side, we need negative 12x. 4 times what gives me negative 12? Negative 3. Do we need to put an x? We took out an x. We need 1x. Do we need to add any more? Not at all. Guys, I'm sure you can see the answer, right? Someone answered a long time ago, and I'm happy for that person that saw the answer a long time ago. We're just making sure that everybody is able to really capture and internalize every single step. Every single step is a byproduct of all that factorization time that you spent when you were doing factorization in class, doing factorization with me in the platform during the holiday. Now it's really materializing because you are like, yo, it's coming. And this factorization, because I've mastered it, it's working for me. And the maths is popping and the marks are marking. So the common things here, guys, can we cancel? Freely. Why? Because there's a bracket multiplied by another bracket makes it one term. There's 4x multiplied by x minus 3 makes it one term. This x minus 3 and this x minus 3 can be cancelled. Who is left behind? X minus 9 over what? 4x. Then my kids are tempted. Say, can I cancel this x and this x? No, my child. No, you cannot. Yes, very good, Tato. I love that we are fighting in the comment section now. It's very true. I love that, and it's very true. Then my child says, x and x say, they are common. Let's cancel. No, my child. I scream. No, don't go there. Why? Because we do not cancel across an addition or subtraction sign. So no, my child. The answer is we leave it like this. No, my child, don't go there. Okay. Hopefully we're together, people. See how easy this is? Do you see how essential your factorization is? Do you see how essential your factorization? Now, if your factorization is still, in crutches, it's still in crutches, your factorization. Then what happens, my beautiful people? Okay, what happens, my beautiful people? The factorization is in crutches. Okay, what happens when the factorization? If the factorization is in crutches, do you see where the danger is if the factorization is in crutches? I hope you see the danger. Right, let's look at this one, and this is my last grade 10 problem for the day. I'll do two more. Then I'll give you your own. Okay. Oh, Sherman, sorry about that. Landy, we're sorry about that. Okay. So let's just hang on there. I see these requests that are coming in, but at the end of the day, guys, I like I said, time limitations. Okay, time limitations. Well, I'll try, Snoopy. I'll try, but the thing is, I'll only be able to do it later on. The reason is, I'm actually tomorrow. I'll be teaching. I'll be going to teach. Yeah, this weekend is a busy one for me. Like I said, I have grade 12 classes. I have a grade 12 classes here. I need to push very strong. Let's look at this one. X minus 2 over x squared plus 4x minus 5 divided by x squared minus 4 over x squared plus 5x. Once again, you beautiful people have already done this thing. You did this thing last year in grade 9.
Didn't you? You did. You did. You did indeed. Alright. Two fractions, this one divided by that one. What did you learn, you guys, when you were in earlier grades in primary? If you are given two fractions like this, 1/3 divided by 1/9, what do we do? What do you do? What do you do if there's a divide? Let's see if there are any people here that remember what we did. Oh, look at Lottie mine there. Lottie mine slipping in the goal there. Dividing is multiple. Multiply by reciprocal. Oh, I like that word, reciprocal. I like the reciprocal. Okay, reciprocal. Yes. So what we do is that the second fraction is usually written as a reciprocal, because when you change divide to multiply, then it is reciprocated. 1/9 is 9/1. Then we proceed from there. Okay? Then we proceed from there. You remember this? Oh, these were good times, weren't they? Okay? And then those people that used to see 3 and 9, there's a highest common factor, you see? Yeah. Then they would do that thing of like saying between 3 and 9, there's a highest common factor. 3 goes into 3 once, 3 goes into 9 3 times. Then the multiplication would happen. 1 times 3 is 3. 1 times 1 is 1. Then final answer, you would get 3. Do you remember those good old days, those good old times when maths was devoid of variables and it was just so sweet? And you do this and you'd be like, maths is so fun. You know? Remember that? I'm sure you guys you reminisce on those times and you're like, maths was so sweeter back then, you know? But now, it's even sweeter. Woo! There's variables. Okay, here we are, guys. Here we are. Yeah, when maths was mathsing, but it's mathsing even now. You see, when you are doing it with maths as a game, yeah, when girls used to cook like their mothers, you know exactly, and they didn't drink like their fathers. Man, Yeah, so hopefully, you guys, we can actually get to a place where we can return the sweet times, Let's make ourselves great again, if you know what I mean. All right. So x minus 2, and return to proper morals. You know what I mean? Yeah, so that we can be that generation that will make a difference, be the change that we want to see in the world. And then we can reflect that more confidently and beautifully. So we're going to do the same thing here. It's no different. First and foremost, let us make sure, before we even do anything with the individual fractions, let us change the divide to multiply and then do the things that need to be done. Yes, exactly. Be that change, like divide and multiply and change, reciprocate everything, Be the change, like divide and multiply and then change things up. Our current reality doesn't have to be our future reality. What we want our future reality to be needs to be a byproduct of the decisions that we'll make now, because those decisions will determine our destiny. So if we make them good, guys, we can really make them good. Be those mothers that really care and can nurture. Be those fathers that can be there and available, not absent, present, fully and completely. Build nations, peoples, and all of that stuff. So guys, x minus 2 over x squared plus 4x minus 5 times, look at this, reciprocal, x squared plus 5x at the top, x squared minus 4 in the bottom. Okay, are we together? Then let's proceed. Now, we'll look at all of these. How many terms? 2. Factorize if possible. How many terms? 3. Factorize if possible. How many terms? 2. Factorize if possible. How many terms? 2. Factorize if possible. How many terms? 2.
Factorize if possible. X, how many terms? 3. Factorize if possible. How many terms? 2. Factorize if possible. How many terms? 2. Factorize if possible. Guys, I'm sure you have been seeing that every time we have 2 terms in a fraction, more than 2, we do what? We factorize. If what? If possible. Does that make sense, guys? Does that make sense? Factorize if possible. We're going to do that now. Factorize. Wire. Cash contant. You know, cash contant stuff. Everyone. You get one, I get one, everybody gets one. Everybody factorized, if possible. Wire. Okay, let's look at this, guys. X minus 2 in the numerator. Let's look at the denominator. X squared plus 4x minus 5. Wow. This is a what, guys? It's a trinomial. But it's that trinomial that is quadratic in nature. Wow. So, is there a highest common factor? Yes. Now we have no misgivings because we got this down. But now let's be careful. Please, let's be careful this time round. And now it's like I'm teaching you guys factorization again. The minus sign for your constant means different signs, not the same this time round. Yo, do you see where the danger is? The minus sign suggests that there are different signs. Where? In the brackets. The minus sign, if the constant is negative, it suggests that there are different signs inside the bracket. But according to the mother, the highest factor will get the positive sign. Guys, this is very key. Yes. Take note, please, people. Different signs this time round. So if the constant is negative, after taking out the negative, please, guys, if the constant is negative, guys, we need to listen to the rule that applies here. It's not the same as the one that we did before. The one that we did before, please take note, guys. Please take note. Remember, the constant was what? Was positive. What did I say to you? Same signs. Do you remember that? I said same signs, and I said, according to the mother, that's how the signs will be the same inside the bracket. That was when the constant was positive. Yo, Bajonga, look at this now. Now the sign of the constant is negative. So what does that mean? Different signs in the bracket. But take note. The mother assigns the oldest child its identity. So in other words, in the factors of 5, the highest factor will get the sign of the mother. Remember, if this was minus and then also this was minus, then it would say also that the highest factor gets the sign of the mother. So we need to listen to the rule for when the constant is negative. I repeat, if the constant is negative, it means different signs. The highest factor of the constant gets the sign of the mother. Gets sign of mother. And this is the key part. The highest factor gets the sign of the mother. Please, guys, internalize this rule. The highest factor gets the sign of the mother. You remember the other one? Hey, guys. Hey. So in other words, plus, minus. That means different signs. The factors of 5. Now we need to think of factors of 5. We have 5 and 1. The highest factor gets the sign of the mother. There it is. Which means there's 1 here. Okay? Guys, please. Those who have ears to hear, let them hear. Because as they hear, and as they understand, and then run home to master. You guys will be 11-7 kind of kids, I tell you. Maths will be so exciting and enjoyable to your heart. You will no longer have a sleepless nights when you are about to write a maths test. You will not have stress. The stress levels will deplete and will go down. So this is very important. X minus 2 over x plus 5 into x minus 1. That's the factorization. You can check now. What's 5 times negative 1? You get negative 5.
Lava plus smoke equals cloud. That's how you make a cloud.
Oh, nice. Okay. And then secondly, yeah, that was my son. 5, that's positive, minus 1 gives you 4. Do you see that? So this works out nicely because the addition of these two should give you plus 4. Does that make sense? Yeah. User 793 is saying, "Sir, can you make another example?" No. User, just listen. I am saying whenever the constant is negative, that means signs need to be different for inside the bracket. And the highest factor gets the sign of the mother. So you have to explore the factors first and then assign the biggest number, the positive sign for those factors. And then you must check which ones when you add give you positive 4. Do you see that? So there's no need for me to do other examples and another example. You need to listen to the concept. That's why I said to the person who was asking me, "Do you do question papers?" Someone asked me, "Do you do question papers?" And I said to them, I do question papers only after I am sure, first and foremost, that we understand the concept that has to do with various questions and various problems under a particular topic. Once we understand that, you do exercises on your own, the beauty of homework at school, then ultimately, me and you will be able to attack exam questions. And we will both be able to attack them without any problem. I'm not finished yet. Remember, there was another side. Okay? Don't worry, Bosisiwe. The others will be delayed if there's a need. Because I will not just start a grade 11 session when you guys, I'm not done with you fully. You know what I mean? I must give you a game challenge and you must go run with it and you must be convinced that what we were doing here was fine. So don't worry, just chill. Leave it up to me, that other thing. So x squared plus 5x, guys. We need to factorize. What is there? Very good, Lerad. Highest common fact. What is the highest common fact? The sign, positive. The number is 1 because between 1 and 5, it's 1. The letter x squared and x, the lowest exponent 1 is x. What are we left with inside? Snoopy ran ahead and shows us it's x plus 5. Hopefully all of us, we understand that. Okay. So here we had quadratic trinomial factorization. Here we have highest common factor. Here in the denominator we have x squared minus 4. This is called what? Difference of two perfect squares. Now I'm sure all of you with dots, guys, you know what needs to be done. You know, we open two beautiful brackets. We take the square root of x squared. We populate our first term with that. The constant is negative. What did I say when the constant is negative? It means what for the bracket? It means different signs. No different from this. Constant means different signs. When the constant is negative, people, it always means different signs. Please take note of that. Then we take the square root of 4, which is 2. We write that 2 there and there. Ah, so beautiful. Now what is left is that we have a beautiful expression. We can finally take this x minus 2 and put a bracket around it so that it can fit the mold of what we mean for it in the numerator. 1, 1, 1, no cancellation across an addition or subtraction sign. Can cancellation happen? Yes, but remember, when we cancel, we do not cancel something that's here in the denominator and something that's there in the denominator. No. When we cancel something, let's say we cancel x plus 5, we need to check Is there an x plus 5 in the top? No. We move on to the other side of the multiplication side. Is there an x plus 5 somewhere here in the top? Yes. Goodbye, x plus 5. Bye-bye, goodbye, goodbye. Then, x minus 2 also has a friend. We cancel him. We cancel him. So why didn't you have 2 brackets instead of having a x outside? Oh, you are asking Momuhle about this x squared plus 5x. Why didn't I have 2 brackets? Momuhle, remember, with every and any question that we do when we are factorizing, we always check first before we do anything. Is there a highest common factor? Here in this expression there was. So what did you do? We took it out. We didn't open 2 brackets simply because we saw that there was a highest common factor. We took it out. Then we are left with x plus 5 inside the bracket. No 2 brackets needed to be opened. Are you with me? Alright, no problem, Momuhle, as long as you understand. As long as you understand. Busisiwe, x squared plus 5x is quadratic. It is, because remember, what makes a quadratic expression a quadratic expression? It's because there's an x term that has its highest exponent as 2. The only thing is that with this quadratic expression, there is a highest common factor. So we take it out. Okay? It's just that it's not a quadratic trinomial. Maybe you can be specific about that. Okay? That's why we don't open 2 brackets. Man, guys, it's beautiful. This one is difference of 2 squares. We know that when there's a difference of 2 squares, we open 2 brackets. Hey! Then all the things that are gone, we know there's 1 left in those places where we have actually cancelled. Because division of something by itself means it's 1. Okay? Are you with me, guys? Then we finish off. We check there. There's 1 times x. So in the numerator, we have x. In the denominator, 1 times x minus 1 is x minus 1 into x plus 2. So in the denominator, we have x minus 1 into x plus 2. And there you have it. No one loves you, knocking down. Wait. Guys. Wait. Alright, guys. I don't know if you feel like no one loves you like I like to. I made you guys wait, join my live, and I'm sure you can feel that this guy, he's really taking his time. He's explaining these things, and he's unpacking the maths. I see you guys. Okay, guys, very important. Okay, yeah, there's the x that's left in the numerator, so we represent it. Then in the denominator, we're left with x minus 1 to x plus 2. We represent that. I just want to do one last one, guys, for you, and then I'll give you your own game challenges to do, and then we can call it a night so that I can actually invite my grade 11s in up in here, So I'm gonna do just one last one. Yeah. In the process, I'm hoping you guys are also seeing how important factorization is. And I'm teaching you factorization as I'm doing this. That's why it's taking a bit longer, because I'm actually literally teaching you what are the concepts that you need to take into consideration when you are factorizing different types of expressions. So let's look at this one. In the numerator, we have how many terms? 2 terms. In the denominator, we have how many terms? 2 terms. And I'm sure you guys can see what those terms actually are. So, let us proceed. X cubed minus 8, this is what we refer to as, this is something that you learned, or you should have learned here in grade 10. We refer to this numerator part as 2 terms that are, we can apply what we refer to as cubic factorization. Good job, Landio. Yeah. At the top, we do that thing. Yeah, you see these people. Yeah, I can see my students here, eh? People who have been here for the longest time. Yeah. All right. Yeah, we do that cubic factorization thing, Landio. Do that cubic factorization thing. And you remember that cubic factorization thing, what it entails? We open a binomial bracket, we open a trinomial bracket. Now, to those who haven't learned this as of yet at school, please do not be anxious or feel like, I didn't know this and all of that stuff. It's fine because you're still going to learn it. And what I'm going to do here is I'm just simply going to answer the question and I'm going to move on and give you guys your own problems to do. Yeah. So please don't be too, too moved. So since this is cubic, it means that we've got a perfect cube and another perfect cube. So what we do when we are doing cubic factorization, we open a binomial bracket. And this binomial bracket will take the order of what we see as the sign in the original expression. So since it's negative, it means our binomial bracket will have a negative. Okay. Then that means for our trinomial bracket, we'll follow it with a positive and a positive. Now, those who actually did cubic factorizations with me in a live session that we once did will know this process. Those who are here and they're like, and this is, please guys, I do encourage you to go to my YouTube channel. An entire lesson I did there for the grade 10. There's a playlist for the grade 10s that you can basically go and watch. You can watch all the sessions that we did during the holiday session where I've covered the different types of factorization. You can take it at your own pace and really unpack every single concept that there is to it, okay? And then you can, things can be simplified. Lerato, unfortunately, I don't, okay? You can't find my YouTube channel bio. Go to my bio, please. If you go to my bio, there are 2 links. There's one that's a WhatsApp channel. Please don't, just leave the WhatsApp channel. Go to the link for my YouTube, and then please go there and download and basically go and watch the sessions that are there. Bokamoso, you are right. I do need to do that. I've been really struggling to download the sessions that I did from the TikTok page. I don't know why it's giving me problems. That's why you see that it's unupdated with the most recent sessions that I did. So, but I'll keep on trying. Okay, I'll keep on trying. Okay, then we are going to take the cube root of x cubed. And the cube root of x cubed is simply x to the power 3 over 3, which is x. Okay, that becomes our first term. Take the cube root of the first term. Take the cube root of the last term without its sign. Cube root of 8 is 2. Okay, that's very important. So the cube root of x cubed is x to the power 3 over 3, which is x. And then the cube root of 8 is 2. So we write x minus 2 for the first and the second term binomial bracket. How did I get x minus 2? The same sign is that one. I take the cube root of x cubed, I get x. The cube root of 8, I get 2. Okay, because this is a perfect cube, Lerado. X cubed is what we refer to as a perfect cube. 8 is also a perfect cube. All right, since it's a perfect cube, if you take the cube root, which is the inverse of it, you will get for the cube root of x cubed, you'll get x. The cube root of 8, put it in your calculator, you'll get 2. All right, it's because this is how we approach cubic factorization. And Lerato, if you want to know the intimate details and the unpacking of it, I please do invite you to go to my YouTube channel and actually go and watch the live session that I did on cubic factorization. Then you will actually understand, because I do a series of examples there, different types, and then I give them a game challenge to do. Then the trinomial here, you square the first term, you get x squared. It's like if you say x times x squared, you should get x cubed. To get the last term in your bracket, you square the last term. So you square the last term. So 2 squared is actually equal to 4. Why? Because 2 times this 4 gives you back the 8. And then to get the middle term, this is simply the product of x times 2. Where does the x comes from? First term of the binomial. Where does the 2 come from? Second term without its sign of the binomial bracket. What's x times 2? Gives you 2x. Okay. So I hope that's clear for you. So in other words, we have x minus 2 into x squared plus 2x plus 4 over now. Yes, the factorization of x cubed minus 8. Yes, all right. And the thing is, if you've forgotten it, or you feel like, no, we didn't do it like this in the holidays, and like I said, I do encourage you to go back and refresh your mind. Maths is easily forgotten when it has not been done for a very long time. So please go kindly review and recheck so that you can remind yourself. Okay. Negative 2 times 4 will give me negative 8. That's where the 4 comes from. Negative 2 times what gives me 8. Okay. Yeah. Or it's like simply saying we square the second term. We square the first term to get x squared. We square the last term to get 4. And then we get the product of the first and the second term to get the middle term. Okay. So hopefully that's clear. Then remember we had 2 minus x in the denominator. 2 minus x. Now this 2 minus x, we are going to apply here something that we refer to as the sign change rule. What is the sign change rule? Yes, you can do that as well, God's favorite child. That's fine. What is the sign change rule? 2 minus x can be written as take out a negative sign because the x is got a negative coefficient, and the assumption is that if it was the first term, we would take out the negative sign. But what would that leave us? It would leave us with x minus 2. Please take note, guys. You see this x? It's negative. Okay. This 2 minus x, if we took out a negative sign, we could rewrite this as x minus 2. We call this the sign change rule. Take out a negative sign and then rewrite this in the order of x first and then the 2 last. You took the negative back into the x. What is negative times x? It gives you back negative x. If you took the negative and you multiply it by the negative 2, you get the positive 2 back. So basically, in other words, we call this the sign change rule. What does that afford you? It affords you the chance to cancel these 2. I hope you guys see that. Okay. Sign change rule applied allows us the chance to cancel x minus 2 and x minus 2. So finally, what do we have as our final answer? If we cancel that and that, okay, and we can cancel it because remember this negative sign is multiplied to x minus 2. It is not a negative that is separating x minus 2 from another term. This is very important. Okay, this negative sign is not a separation sign. It is a negative that is multiplied to x minus 2. The only time we cannot cancel, and we say we cannot cancel a cos and addition and a subtraction sign, is if that sign is actually a separation sign to another term. Okay. Yeah. Yes, also we're going to do that after 11. Okay. Yeah. So hopefully you can see that we cancel those 2. What are we left with as our final beautiful answer? We are left with x squared plus 2x plus 4 over negative 1, because remember if you cancel those 2 you are left with negative 1 in the denominator. because there's a 1 and a 1 that remains, because something divided by itself is 1. And then the final answer would be that negative sign. This divided by negative 1 is negative into x squared plus 2x plus 4. And someone else will distribute this negative, and it will basically give you negative x squared minus 2x minus 4. So from here to this final answer, and that's that. Okay. So guys, I think I'm gonna hold it right there. Okay. Kalogo, the 1 is coming from the fact that if you take this and divide it by negative 1, it can be written as negative into x squared plus 2x plus 4. So I'm putting brackets around because the negative sign is divided by that. It becomes a positive divided by a negative is ultimately what? A negative that. Then the negative sign, if you distribute it to the 3 terms, becomes negative x squared minus 2x minus 4, which becomes your final answer. Okay, so yes, I'm going to give you homework nyana, or we call it here at home as game challenges. So I'm going to give you those. You can do those, and you're more than welcome after you're done to actually send these to me. It can be privately, send me a message with your attempts. Okay, so game challenges, we are supposed to do what? Simplify. This is simply simplify. 4a squared minus 8a over 4a I don't know if this is what we call homework nyana, but it's game challenge nyana. So yeah, I think we can. Okay, so you can screen grab this, and then yeah, we'll call it a night there. No? You can screenshot this, and then please please feel free to go and check. These are just a few of the problems. Doesn't mean like this is the be all and end all of all problems that can ever be there, but these are the ones that maybe I'm just checking to see if you guys can do. Just challenge yourself and see what comes out from that. Okay. Okay. All right, so guys, thank you so much. It was good. See you later, alligators.
Yeah, and then I'll try and post this as soon as I possibly can, as soon as I'm done with whatever I'll be doing with the grade 11s and 12s. But thank you so much. Have a good one, and we'll see each other again. I don't know, Liso, because the thing is, like I said, even this, I'm sure the grade 10s that have been joining consistently are like, yo, where have you been? The thing is, it's quite busy, so I can't really guarantee a session when and how. Like, for instance, even now, this was really sporadic, spontaneous, if you will. So, we'll see. When opportunities arise, I will arise, and we'll see each other. Okay, thank you so much, guys. It was good, it was real. Have a good one. I'll see you when I see you. And remember, maths is a game. It's a game challenge. You need to play it, learn the rules, pass with distinctions. Let's learn the rules as much as we can. Yeah, so yeah. Otherwise, cheers.